November 13, 2020. Wacker Polysilicon, North America, in Charleston, Tennessee. One worker was killed and 2 others were seriously injured when attempting to escape a hydrogen chloride gas release. An additional worker was injured from exposure to the hazardous hydrogen chloride. Wacker's Charleston, Tennessee facility manufactures various silicon-based materials that are used in the production of a variety of products. On November 2, 2020, the company initiated a 2-week turnaround of its hydrogen chloride regeneration unit to perform routine maintenance as well as equipment upgrades and repairs. To assist with the turnaround, Wacker employed contract workers from multiple companies, including Jake Marshall and Penn Gulf. On the morning of November 13th, Wacker issued a work permit to Jake Marshall to perform maintenance on a heat exchanger's vapor outlet piping. The work was to be done while hydrogen chloride was actively flowing through the piping. Exposure to hydrogen chloride gas can cause injuries, ranging from irritation of the eyes and lungs to severe burns or death. To protect themselves from those chemical hazards, the Jake Marshall contractors wore full-body chemical-resistant suits, rubber boots and gloves, and full-face respirators with acid gas cartridges. The maintenance took place on the 5th floor of an equipment access structure, which only had one staircase for entry and exit. That morning, contractors from Penn Gulf were also working on the same 5th floor platform. The Penn Gulf employees, however, were performing insulation activities that were not expected to involve potential exposure to hydrogen chloride. For their insulation work, the 4 Penn Gulf contractors were wearing the minimum personal protective equipment required by Wacker: flame-resistant clothing, steel-toe safety boots, as well as safety glasses and hard hats. They had escape respirators and safety harnesses in their possession, but were not actively wearing those items. The Jake Marshall contractor's task was to tighten bolts on the heat exchanger's vapor outlet piping in order to minimize leaks. The amount of force required to tighten a bolt is based in part on the materials of construction of the equipment being connected. The amount of force is called the torque requirement. The vapor outlet piping included both a nozzle made of graphite and lined piping constructed of carbon steel. In this case, the torque requirement for bolts connecting steel to steel is higher than the torque requirement for bolts connecting steel to graphite, as graphite is a very brittle material. But on the day of the incident, Jake Marshall pipe fitters were not given written specifications for every bolt they would tighten. A Jake Marshall journeyman provided an apprentice pipe fitter with a torque wrench set to 40 foot-pounds, which is the setting for tightening the steel-to-steel connections. After tightening the bolts requiring 40 foot-pounds of torque, the pipe fitter then used the torque wrench to tighten bolts on the steel-to-graphite connection. But the manufacturer recommended torque value for those bolts is only 15 foot-pounds. As a result, the bolts were inadvertently over-tightened. At 10:04 a.m., the excess torque applied to those bolts caused the heat exchanger to crack. Hazardous hydrogen chloride released to the atmosphere between the workers and the only available staircase. Within 15 seconds, a large hydrogen chloride cloud filled the area, preventing the workers on the platform from seeing their surroundings. The apprentice pipe fitter quickly moved away from the release. As he did, his chemical suit became entangled on surrounding equipment and tore open. This exposed him to hydrogen chloride, which caused chemical burns. In the chaos, he bumped into equipment on the platform, which knocked off his respirator. Although he was located closest to the staircase, without a respirator, he could not pass through the hazardous cloud to exit. Instead, he moved to the opposite side of the platform where the other contractors had been working. 3 of the 4 Penn Gulf employees put on their escape respirators. But without chemical suits, they were unable to walk through the cloud to reach the staircase located on the opposite side of the platform. Instead, they attempted to climb down piping on the side of the structure, which was approximately 70 feet high. While climbing down, all 3 fell to the ground. One worker was fatally injured from the fall, and 2 sustained serious injuries. The remaining Penn Gulf worker was able to put on her escape respirator with help from a Jake Marshall worker, who, wearing chemical-resistant PPE, also attempted to shield her from the hazardous hydrogen chloride. The dangerous release continued for approximately 3 minutes, until all the gaseous hydrogen chloride had escaped from the system. After the release stopped, the 3 Jake Marshall workers and 1 Penn Gulf worker used the staircase to evacuate the area and safely reach the ground. The Chemical Safety Board launched an investigation and found 4 key safety issues contributed to the incident. They are written procedures, control of hazardous energy, simultaneous operations, and means of egress. The first safety issue concerns written procedures. OSHA's Process Safety Management Standard and the EPA's Risk Management Plan rule required Wacker to implement written operating and maintenance procedures for covered processes and equipment. These should have included clear instructions for how to tighten the different types of connections present on the heat exchanger's vapor outlet piping. But the CSB found that Wacker did not have a written procedure to execute the task. Instead, Wacker relied on verbal instructions and the piping manufacturer's equipment manual to communicate the torque requirements to the Jake Marshall contractors. The manual, however, did not include the torque requirements for the bolts that were eventually over-tightened. Those requirements were included in the manufacturer's drawing of the heat exchanger, which the Jake Marshall pipe fitters did not have in their possession at the time of the work. The CSB learned that the correct torque requirements were verbally communicated by the Wacker permit authorizer to the Jake Marshall foreman. The foreman then relayed the torque requirements to the journeyman pipe fitter, who finally communicated the information to the apprentice, who ultimately tightened the bolts. But the lack of clear written information and reliance on verbal instructions increased the likelihood of miscommunication and misunderstanding of the task and precautions. As a result, the CSB recommended that Wacker develop and implement a formalized SIMOPS program addressing co-located work tasks. The CSB also determined that industry guidance regarding SIMOPS has largely been restricted to offshore processing, such as oil and gas drilling. In fact, during its investigation, the CSB was unable to identify any codes, standards, or regulations specifically relating to the identification and control of SIMOPS for maintenance activities conducted on stationary source chemical processes.